In this video, we go over everything you need to know about direct and inverse proportion for the foundation level at GCSE. So let's dive right in. What is proportion? Well, when we're thinking about proportion, I'll show you how we write it. We use a fancy symbol that you won't have seen before. It looks a bit like a fish. You should have a go at drawing it. It's actually quite hard, called the symbol of proportionality. This simply reads y is directly proportional to x. So in proportionality, it's like a ratio. We have two variables, x and y, and they increase at the same rate. So they're in a ratio. So we might have 1 to 3 x to y, and that's a ratio. That's the ratio that the two variables are in. So we have 3y's 1x. Let's draw a t-table. Whenever proportionality, think t-table. Just want you to think about one of these tables, because this is how we're going to work it out. And basically, what any question is going to ask you is they're going to give you this. They're going to say, for every x, we have 3 y's. And then they're going to tell you, well, we have 5 x's now. How many y's do we have? Let's put it in the table. And what I've said directly proportional means they're increasing at the same rate. So if this is increasing, that we're multiplying this by 5, what are we going to do here? We're going to multiply it by 5 because we're increasing them at the same rate. So we can multiply and divide. We can't add. That's not at the same rate. That's doing the same thing, but it's not at the same rate. At the same rate is multiplying and dividing. So this, we can see 1 to 5 is multiplied by 5, so 3 to 5 is multiplied by 15. Now, chances are you're not going to get two random variables, y and x. You're going to get pounds and dollars. So let's think about a question. We're told that the exchange rate from pounds to dollars, is 1 to 1.2. That's our ratio. Draw a t-table for it, because we're told that pounds to dollars is 1 to 1.2. Just that kind of thing, you know you're in a ratio and proportion kind of thing. So draw a t-table out for it. That's what I need you to do. And then maybe you're told that, well, how many dollars can I get for £10? Well, we do the same thing, times 10, times 10. That's it. It could be eggs and flowers. I have 2 eggs and 120 grams of flour, and you are asked to find out how much flour you need for 7 eggs. It's literally just doing the same thing to each side, timesing and dividing. Okay. The other way you might see it is, let me show you. From x to y, we're timesing by 3. Can you see that? And when they're directly proportional, we're always doing the same thing. So we could see y equals 3x because we're always timesing x by 3 to get to y. So if I have 10x, you might see it written like this, and all you need to do is substitute in y equals 3 times 10, because we're substituting the 10 in, equals 30, and we know that this is 30. You can see here because we've times both sides by 2. So there's a second way to think that you may get given it this way, you may get given it this way, but more often than not, they're just going to give it to you as a worded question. Now, inverse proportion is a little bit different. So x, you have x, the inverse of x is 1 over x. Now, you don't need to worry about that too much. All you need to worry about is that this means y is inversely proportional to x, okay? Now, inverse proportion it's even more fun than direct proportion, trust me, it really is. So we have x and y. Let's say we have 2 x's and 4 y's. Draw our t-table, because we're dealing with proportion. Always think, link the two in your head. And let's say we have 6 of x. How many y do we have if they're inversely proportional? So y is inversely proportional to x. So on this side, we're timesing by 3. Now, it's not direct proportional. We're not going to do the same thing to each side. It's inverse proportion. So inverse proportion, we're going to do the opposite thing. We're actually going to divide by 3. So 4 divided by 3, 4 over 3 is what we're going to get. Let's pick 1. So from 2 to 1, we're dividing by 2. Yeah? And how many y's are we going to have? Well, from 4, well, we're not dividing by 2, are we? It's not it's inverse proportion. We're going to do the opposite. 4 times 2, with multiplying by 2, doing the opposite. So 8, if we have 1x, we have 8 y's. Now, the question you're going to get is you're going to get told something like, we have 16 builders who complete a task in 4 hours. If 24 builders work on the task, how many hours? So maybe have a go at this one. See if you can work it out. Pause the video. Here's the solution. Hope you've done your T-table. Builders B, hours H, T-table, 16 builders, 4 hours. Watch out, watch out. They won't say something is directly or inversely proportional to something. They will tell you 16 builders in 4 hours. You see like a relationship, an almost ratio relationship, and then you get told something else. Always think T-table for these kinds of things. Always do T-table. If in doubt, T-table. And then 24 builders, how many hours? So 16, well, first of all, we need to work out what we're doing from 16 to get to 24. Well, how I like to teach this is 16 multiplied by something, give it a question mark, is equal to 24. Yes? We don't know what this number is, so what we're going to do is we're going to call it x, because x is an unknown number. That's all it is. It's a variable. That's algebra. If you're not sure on this, go back and review your algebra knowledge. So to get x on its own, solving a one-step equation, we're going to divide both sides by 16. So 16 divided by 16 is 1, so we get x on its own. 24 divided by 16, 24 divided by 16 is, on your calculator, 1.5. These are calculator questions, so we know that times 1.5 is 24, so we're not going to times by 1.5 here, we're going to divide by 1.5, because it's inverse proportion. You've got to be careful, because they're not going to tell you whether it's direct or inverse proportion. You've got to work it out. So you've got to think, okay, if we increase the number of builders, are more builders going to take longer, or are they going to do it quicker because there's more of them? They're going to do it quicker because there's more of them. Therefore, it's inverse proportion. Whereas the last one, if we increase the number of pounds, is our number of dollars going to decrease? Does that make sense? No. No. So just be careful. And then on your calculator, you're going to do 4 divided by 1.5, and that should come out to be, if my calculator is correct, 2.6 recurring, or you can write it as a fraction, 8 over 3. So 2.6 recurring, or 8 over 3. The numbers may seem horrible, but all it is doing the same thing either side. Trust your calculator, okay? Trust your calculator. Your calculator is your lifesaver in these exams. Here's an example exam question that could come up around proportion. Again, it's going to be a worded question. They're not going to tell you, oh, something is directly proportional to something, calculate this. They're going to simply give you a worded question, and you've got to decode it. So pause and have a go, and then I'm going to go through it. So the solution, what you've got to do is you've got to read through the question and find the relevant bits, the bits that they actually want you to work out. Because you can see down here it's going to be 3 marks, so you know you're going to have to do a bit, but not that much. So Scott wants to make orange juice. He's going to buy boxes of oranges. Don't really care. That's no numbers. There's no numbers. That's completely irrelevant. It's a little bit of context, but we don't need to know that. There are 24 oranges in each box of oranges, and 30 oranges make 2 litres of orange juice. So generally, stuff in boxes is more relevant than the first couple of sentences of the question, because they'll try and give you a bit of context, but this is the stuff that you'll really need. So we're going to underline this, and you can see this, and this is like a proportional relationship, right? Because as we increase the number of oranges, we increase the amount of orange juice we can make, so it's going to be directly proportional. And Scott needs to buy enough oranges to make 8 litres of orange juice. So this is the bit you need to calculate. You're told that 30 oranges make 2 litres of orange juice, and Scott needs enough oranges to make 8 litres of orange juice. Now, before we jump ahead with our T-table, we'll finish reading the question, and we want to work out the number of boxes of oranges that Scott needs to buy. So that tells us that at the end of the question, this top bit that we've underlined might be might be relevant. So let's draw out our tea table. We've got oranges and we've got litres. Make that O a little bit clearer. Nice tea table. We've got 30 oranges, make 2 litres of orange juice. We want to make 8 litres of orange juice. So remember, directly proportional, we're doing the same thing to both sides. So what we're doing to get from 2 to 8, we're timesing by 4. What we're doing to get, well, what do we have to do to this side? Therefore, we have to times by 4. And that means that to make 8 litres of orange juice, we need 120 oranges. Is this our answer? No, it's not, because we need to know the number of boxes of oranges that Scott needs to buy. So we can always draw a second tea table, can't we? So we can have boxes and oranges. So one box contains 24 oranges, yes, using the information at the top. And we know that we need 120 oranges. So 24 to 120. Now, if you can't do that in your head, what we're going to do? Well, we're going to try and figure out what times by 24 equals 120. Well, this is our unknown number, isn't it? So we can call it x, and then we can solve to get x equals 5 by dividing by 24. Divide both sides by 24. So 24 times 5, you can check that with your calculator, equals 120, and therefore 1 times 5 is 5. So therefore, Scott needs to buy 5 boxes of oranges, and that's our final answer, isn't it? We'll check with the question, work out the number of boxes of oranges that Scott needs to buy to make 8 litres of orange juice. He needs to buy 5, so that he has 120 oranges, so that he can make 8 litres of orange juice. There we go, we've solved the question. So you can see there's lots of words in there, but really there's only a little bit that's relevant. It's more than just one simple direct proportion, but actually it's really simple. The challenge with foundation questions is reading through the question and picking out the bits that you actually need to work with. So practice that and you should be fine. This stuff is really simple, just doing the same thing, all the opposite stuff if it's inverse proportion to both sides. Hope this was helpful.